record this class. And I'm going to share my screen. I did create the next homework assignment. So I don't really know when it's due yet because we haven't done everything that's on it. But, you know, if you get bored and you have nothing better to do and you want to start calc homework, go right ahead. Everything's there for you. Okay? So we are, I don't even remember what this section is talking about. Fundamental theorem of calculus, right? So we were working with the fundamental theorem of calculus part 1 yesterday. And I just wanted to do one more problem so that you could see that this fundamental theorem of calculus, why do I want to do one more problem? Do I really want to do one more problem? I don't think so. Nope, I don't want to do one more problem. There we go, okay. What I do want to talk about, though, is the fundamental theorem of calculus part 2. That's not how you spell fundamental. There we go. Which is basically something that we've been doing all along on our own, okay? Which is to say that if I take some integral from a to b of f of x dx, that this is equal to f of b minus f of a, where capital F of x is the antiderivative of f of x. And let me write out antiderivative more clearly. Go ahead.
So when you use the capitals, does that mean it's a different equation?
Yeah.
Oh.
Yeah, that's exactly what it means. Okay. So for instance, if we start with, let's see, there are some practice sheets in here. So if we go to part 5 here, if we do the practice sheets for the fundamental theorem of calculus part 2, let's just take one here, okay? So this is fundamental theorem, this is practice-FTC part 2. So let's just take number 3 here, okay? So that is the integral from 1 to 3 of 2x squared minus 12x plus 13 dx, I believe. Okay. So this part here is little f of x. And what I'm going to do is the only way I know how to take antiderivatives at this point. I'm sorry, the only way I know how to evaluate integrals at this point is either to take the area under the curve or to take the antiderivative. Okay? And I can use the power rule here to do that. All right? So what's the antiderivative going to be of f of x? All together now. 2x to the third divided by minus 12 times x to the 2 divided by 2 plus 13x, okay? So if this was an indefinite integral, it would have been plus c, okay? But it's a definite integral because I'm looking at a very specific interval. Now, the way I do this is then I would make this blue line, and I would write from 1 to 3, okay? This thing here is capital F of x. It is the antiderivative of f of x. Now, this is one of those things where nobody's ever going to say, given this, given little f of x, find big F of x. Okay, that's not the way we do it. We say, use the fundamental theorem of calculus part 2 to evaluate this integral. And you're not even going to think about it. You're just going to take the antiderivative and then evaluate. Okay? So to continue this problem, what do I do? Okay. So I plug in the upper limit, so that's going to give me 2 times 3 cubed over 3 minus 6 times 3 squared plus 13 times 3 minus, and then I take my whole thing and I substitute in 1. Got a little parentheses happy at the end, okay? And that's equal to something. I have no idea what it is. I don't even know if I care. Okay? $18 minus 54 plus 39 minus 2/3 plus 6 minus 13. It's going to give us something. This may be the end of my interest in it. So 30. $55 and a third? That's my guess. I have no idea. It doesn't matter. You end up with an answer. Okay? All right? So again, as with many things that we're going to be doing now, don't get hung up on identifying little f and big F. Understand the process, because that's really the way it's going to be happening, is understanding the process. Okay? So I believe that the next thing is there's an example for you to try. The integral from 0 to 5 of x to the 3 halves dx. So you try to come up with an answer for that. The AP exam always goes with 3. for AP Calc. Physics is different. Physics go with sig figs. Okay. I'm going to tell you that my answer, before you give me that decimal, is 10 radical 5. I could be wrong, but I don't think.
No, I just used I just put it as a decimal, but I don't if you take that decimal.
Same thing? Awesome.
Yeah, it is.
Okay, great. Okay, so are there questions on, I think checkpoint 19 has to do with this. 5.3. No, we good? Okay, we've kind of been doing this all along. It's just that now we're making it official. Okay. All right, then I have a couple of examples that I would like to do. Okay. So I have no idea what example number we're on, but it's the integral from pi over 6 to 5 pi over 6 of cosecant squared theta d theta. Okay. So again, when you come to an integral, whether it's a definite integral like this one or an indefinite integral where we add the plus c, you're going to have a list of techniques that you can use to evaluate that integral. And the first thing, which we talked about yesterday, is what I call inspection, which means, do I look at that and say, I know what the antiderivative of that is? So you have to ask yourself, do you know what the antiderivative of cosecant squared theta is?
It is.
Got it, Fiona?
Yeah, it is. Negative cotangent x.
Cotangent theta, but
Yeah.
yeah. Okay. All right, do we agree with her? You got to know those. She's right. But that's why we did that exercise. I think it was before winter break with with connecting all of the things in their derivatives, okay? So we're going to evaluate that from pi over 6 to 5 pi over 6. And here is a good place to use decimals. So remember, since your calculator probably doesn't have a cotangent button, what is cotangent in terms of things that you know? Okay, so it'll be negative cosine theta over sine theta, evaluated from pi over 6 to 5 pi over 6. And what do you get? What'd you get, Annabelle?
I got a 3.46.
Let's see what other people got.
What did she get?
What?
What did she get?
I can't hear you, Kim.
What did she get?
That's what she got.
Oh, yes.
Okay. No? All right, try that again. Parentheses might be something that you need, Dagny. Yes, no? Okay. Dagny? All right, we'll move on. Okay, so the next example talks about Archimedes, right? Can somebody use their, who isn't Dagny, because Dagny read like all the problems in AP Physics. Can somebody who isn't Dagny use their best pandemic voice and read us the beginning of this problem through part A? Sophie, go for it.
How did you put that?
Archimedes.
Archimedes discovered that the area under a parabolic arc is always 2/3 the base times the height. Find the area under the parabolic arc. Y equals 6 minus x squared. On the interval of x is greater than or equal to -3 and less than or equal to 2.
Okay. So part A asks us to find the area under there. So how do we find the area under a curve? What do we do, Dagny?
Oh.
Yeah, it's like the integral, okay? So we're going to take the integral from -3 to 2 of 6 minus x squared dx. Again, we've come to an integral. The only tool we really have right now is to take the antiderivative. Fortunately, this is a power situation, right? It's polynomial, so we know how to deal with that. Dag.
When do you have to break it up into components? Like why wouldn't you break this up into -3 to 0 and then like 0?
Because I don't need to.
Okay, so like when would you need?
When you're applying the fundamental theorem of calculus part 1, and so if I was taking the derivative of this, so let's say actually I was taking the derivative of the integral from x to x squared of 6 minus x, this couldn't be x's anyway, they have to be t's, minus t minus t squared dt. That's when I would have to find a constant in the middle and break it up, okay? But not here. Here I just have a definite integral, okay? So you guys figure it out. What is this area going to be? Give it to me as a fraction. I'll give you a hint. The denominator is 6. What do we got? Who's got an answer? What do you got, Annabelle? 125 over 6. Is that what other people get? Yep. Okay. I see some head nodding. All right. So that was part A. Part B is to find the height of the arch. So remember that what I have here is some parabola that goes from x equals -3 to x equals 2. And there's going to be some height here. And this point is known as what? What? It is, but I was thinking more of a geometry thing. It will, in fact, be the maximum.
Vertex?
Yes, it's the vertex. Thanks. Okay. So, how do you find the vertex of a parabola? You could look it up online if you want.
It is, you need to find out the 0 first and use the middle point of 2, 0 and put it in the function, and then you can find the vertex.
Okay, so we need to figure out what this point is, what that x value is. So what's that x value going to be? What's that x value going to be in the middle there?
A -0.5.
Okay, so -0.5. And then the height that we're looking for is going to be y of -0.5, which will be what?
Um, 6.25.
Okay, so again, let's make it 25/4. Okay. I'm in a fraction-y kind of mood today. Okay, we all good? Yes, no, yes, okay. I know it's a gloomy Tuesday. Some of us have already suffered through AP Physics. It's a long class. It's a long class. I even let you out 10 minutes early. Okay, so part C says show that if we take 2/3 space times height, we're going to get 125 over 6. Okay. So obviously I know what 2/3 is. I have a height there. What's the base? Katie, what's the base?
5.
Yeah. Okay, it's going to be that distance between -3 and 2. And that's going to be times 25 over 4. And if I do a little canceling here, that's going to give me 125 over 6. When is this class?
20.
20? Oh, we got plenty. Plenty of time. All right, so there's one more example that we're going to do today, and then tomorrow is drop day, and Thursday we will do 5.4. I think that's on the portal. We will probably do 5.5, start 5.5 on Friday. I will add that to the portal, but everything is up there so that you can go through the reading guide and stuff, or the journal outline.
So the homework that the graded homework won't be due this week.
For 5.4, Yeah, no, that won't be due this week. Yeah. Because we won't get through it. It'll take us at least Friday and Monday to get through substitution. Because it's just a brand new thing that we need to practice. Okay. All right. So the last example that I want to do is this one. So f is a differentiable function whose graph is given below. So I'm just going to copy my graph into here and make it smaller. But so that I can see it. Okay. Whose graph is given in the figure. The position at time t of a particle moving through the coordinate system is given as s is equal to the integral from 0 to t of f of x dx in meters. And we're supposed to use the graph to answer the following questions. So this is very typical of a question that you, excuse me, will get on the AP exam. Okay, it is very important to remember that what is graphed is f of x. Okay, not s. All right, so Eva, read us part A. Okay, what is the particle's velocity at t equals 3 seconds? How do I get velocity? What is velocity equal to?
First derivative.
What?
The first derivative.
The first derivative of what, Kim?
F of x.
Not f of x.
S.
S, yes. Okay, so that's going to be ds dt. Okay. So I have a function for s. So that's going to be d by dt of my integral from 0 to t of f of x dx. So what am I going to use to evaluate that? What do I do when I take, what's my theorem when I'm talking about taking the derivative of an integral? What theorem did we spend yesterday talking about? Calculus, right. Fundamental theorem of calculus part 1 in this case, okay? Do I meet the criteria? Is the lower limit of my integral a constant? Yes. Is the upper limit of my integral just a variable? Yes. Nothing funky, okay? It's not a function of t, it's just a t. So if I take the derivative of that integral, what am I going to get? Come on, what do? It's real simple. Just replace x with t. So I get f of t. Okay. So I want to evaluate this at t equals 3. So what's f of 3 equal to? Kim?
0.
0. Okay, I can just read it off the graph. Okay. Katie, read us part B.
Is the acceleration of the particle at time t equals 3 seconds positive or negative?
Okay, how do I get acceleration? It's the derivative of what? The derivative of v. Okay, so the acceleration is going to be dv dt, which means I'm taking the derivative of f of t. And what's the calculus, well, what's the non-calculus word for derivative? Slope. Okay, so I'm going to look at the slope at t equals 3. So what's this, and all I want to know is it positive or negative? So what do I know about the slope at t equals 3? It's positive, right? So that tells me that my acceleration is positive. Okay, we good? All right. Harvey, read us part C, please.
What is the particle position at t equals 3 seconds?
All right, position at 3. So I'm just going to take my expression for position and substitute in 3. So I'm going to take the integral from 0 to 3 of f of x dx. And then I can do this at least 2 different ways. What are you thinking about? How can I do that? How can I evaluate this integral? What are the 2 ways you know how to evaluate an integral at this point in your life? Dagny, what's one? So we could find the area under the curve. Could we do that easily? What is that shape? It's a triangle. Can you find the area of a triangle? Yeah. Okay. What's the other way you know how to evaluate an integral? Somebody other than Dagny. She won't be sitting next to you in the AP exam. How else do we do it? The antiderivative, okay? What does f look like from 0 to 3? What shape is it? It's what?
Triangle.
That's the area under the curve. What does f look like from 0 to 3? It's a straight line. Can you find the equation of a straight line? Oh yeah, in your sleep. Okay, so you could find an expression for f of x between 0 and 3. Really, you can find it all the way to 6 because it's the same straight line. Okay, so you could do that and then take the antiderivative of it. And you could do that if maybe the shape wasn't as easy to evaluate. Okay, so do it. Tell me the area under the curve. What do you get, Katie?
I got -9.
-9. Should it be negative? Yeah, it's under the curve. Okay, I'm moving back and forth along the x-axis. I could very easily be someplace negative. Okay, are we good? All right. Lily, can you read us part D?
When does the particle pass through the origin?
Okay, when does the particle pass through the origin? How does that fit into my problem here? what do I want to be equal to 0? The particle's what? Tia. The position. And what's the symbol that I'm using for position? Yeah. So I want to know when S of t will be equal to 0. So remember that my S of t is my integral from 0 to t of f of x dx, and I want to know when that's equal to 0. What does that mean? What? It doesn't have to be a straight line on the origin. Well, okay, you want to relate it back to the graph. Remember, the graph is of f of x. So how is the position related to the graph? So what? Nope, just what is this here that I'm underlining? What is that? It's an integral, right? And what does integral mean? Area under the curve. So what am I really looking for? The time when what? Dagny. You're going to say what?
I was going to say the maximum, but it wouldn't make sense.
No. Sophie, you want to try?
Would it be where your crosses the x-axis, or where the net area on top is equal and opposite to the net area?
Yes. It's going to be where the area below the curve and the area above the curve are equal, right? Because I need to add those two areas up. It's going to give me the net area, and I want the net area to be 0. So I already know that this area here is -9, right? So where do you think, what time is going to give me an area, a total area that's equal to 0? Annabelle, you want to try again? 6 seconds. Is that what you were going to say, Kim? Okay, so that's going to be an area of 9. Okay. So if I take the integral from 0 to 9 of f of x dx, that's going to give me a distance of 0.
Can you just write that for an answer, or do you have to give this 9 seconds?
Oh yeah, you probably you need to write t is equal to 9 seconds. Yes, you do. You absolutely need to choose. Thank you. All right, Kim, read us part E.
Approximately when is the acceleration equal to 0?
Okay, so we need the acceleration to be equal to 0. What's the acceleration equal to again? Okay, so it's dv dt, which means that it's also df dt, right? Didn't we have that on the last screen? Right? Okay, and I want that to be equal to 0. So what does that mean, df dt is equal to 0? Dagny. Yeah, and what kind of place is the slope equal to 0? At a max or a min. So if we go back and look at our graph, where is there a max or a min? At t equals 7 seconds up here, right? I don't know if we're going to be able to do this last part in less than a minute, but we'll try. Harvey, what's up?
For the part before that, why is t equal to 9 and not 6?
Because I miswrote.
Oh.
Good call. So it is. I was thinking of what the area was. So no, you're right. It is 6 seconds. Okay. So we don't have flex today, but you should stay here if you don't have anywhere else to go. We'll finish this problem on Thursday, and we will work on 5.4, which should probably take us through. And like I said, we will start 5.5 on Friday. Okay? Goodbye, my Zoom friends. It is nice to see you. Yvette, I'll see you tomorrow morning for advisory. Bye, Fiona. See you tomorrow.
Oh, I appreciate it. I thought that's not. No, I don't know.